Assalamualaikum and good morning to Dr. Najiha and everyone present. Today I will be presenting our project and automated noise analysis. Here is why this project matters. The problem: noise pollution is a major environmental issue that affect human health, particularly hearing, sleep quality and stress levels. The need regular noise monitoring is essential to maintain a safe environment and comply with environmental standards. The tool Python provides an efficient way to automatically process, analyze, and visualize noise data. For this project, we developed a Python-based noise analyzer that classifies sound levels and generates statistical results and graphical visualizations. Let's dive into the details.
The objective of our mini project is develop a Python program to analyze noise pollution data, calculate and classify those sound intensity level accurately, visualize the environmental data using clear structure graph, communicate our engineering finding through professional reports and presentations, enhance our problem-solving and collaborative teamwork skills. Moving to our problem statement. First, health hazards. Uncontrolled urban noise directly cause stress and hearing loss. Second, inefficient tracking. Manual calculations are simply too slow and error-prone for rapid environmental assessments. And finally, poor visibility, a lack of clear data visualization makes it difficult to spot unsafe limits quickly.
Next, for the methodology part. For this project, 5 different locations were selected, which are a traffic area, recreational park, cinema, classroom, and arcade game zone. Sound level data were collected using a sound meter application and recorded every 5 minutes. The data were then entered into a Python program. The program calculated the average, maximum and minimum noise levels, categorized the readings and generated a graph for data analysis and visualization. The collected data and results were discussed and later made conclusions to see whether the objectives were achieved.
First, import the matplotlib library for plotting the graph. Then, create two lists, which is time and noise level data. Then, for average calculation, calculate the total average, maximum and minimum noise value. Also, find the time when maximum and minimum noise. For load on condition statement, print a format noise analysis table using a load. Then use conditional statement to classify noise as safe, moderate and dangerous. Then display the average, maximum and minimum noise result. Then plot the noise data using a line graph with markers. Add the horizontal line to show the dangerous noise limit. Then label the axis, title and customize the graph. Finally, display the graph using plt.show. And this is the graph and also the result.
Next, let's look at our data for question 1, the school line highway. Our program calculated an average noise level of 76 dB with all reading falling under the moderate classification. However, looking at the graph, the noise clearly fluctuates with traffic density. In fact, it peaked at 80 dB at 5:25 p.m., touching the dangerous threshold line due to heavy traffic expo. Engineers can directly leverage this visualized data for road design optimization, planning sound barriers, or conduct WHO compliance assessment.
Okay, next, for the recreational park location. The average noise level recorded was 66.3 decibels. Based on the graph, the noise level fluctuated throughout the monitoring period, with the highest reading of 78 decibels recorded at 5:35 p.m. and the lowest reading of 58 decibels recorded at 5 p.m. These fluctuations were mainly caused by activities such as children playing, people jogging, exercising, and visitors talking in groups. Although the noise level did not exceed the hazardous limit of 85 decibels, it was higher than the recommended daytime guideline for the recreational areas. The recreational park can be considered moderately noisy during peak evening hours due to active public use. To reduce noise levels in the park, more trees and shrubs can be planted as natural sound barriers. In addition, awareness signboards can be installed to encourage visitors to maintain a quieter environment. The Python program successfully analyzed the data and displayed the results in a graph, making it easier to understand the noise level pattern at the location.
Next, let's look at location 3, cinema halls at JSC Aman Central. The overall noise classification for this environment is moderate, with a recorded average noise level of approximately 74 decibels. Looking at the graph, our level fluctuated throughout the session, starting at a minimum of about 68 decibel at 1 o'clock in the afternoon and reaching a maximum peak of around 80 decibel at 1:30 in the afternoon, which touched our danger threshold line. This noise fluctuation directly reflect the shifting intensity of the film content and natural audience reaction, such as louder and applause. Fortunately, the venue built in acoustic design, specifically the soundproof walls, acoustic panels, and cushion seating, works effectively to control and absorb the sound. While the peak noise level of around 80 decibel technically remains within acceptable limits, reaching that level highlights a clear need for regular audio system monitoring to ensure it stays well regulated.
For location 4, the seminar room at Pusat Pengajian Dormitory, the average noise level was 54.1 decibels, close to the 55 decibel limit. The highest reading was 58 decibels, while the lowest was 50 decibels. The noise mainly come from student discussion. To reduce noise, acoustic panels and awareness campaigns are recommended.
Next, let's look at location 5, which is Arcade Game Zone, Palo at Central ICT. As shown in the graph, the noise levels here are highly concerning. All 10 readings completely exceed the 80 dB dangerous limit. The average noise level was 87.77 dB, which is officially hazardous. We hit a maximum peak of 91.3 dB at 3:25 PM, and even our lowest reading at 3 PM was a high, which is 84.5 dB. The main drivers behind these numbers are the arcade cabinets, racing simulator, and also the crowds. Because this is enclosed space with marble floor, which is it can reflect 98% to 99% of the sound, which is the noise get trapped and amplified. This environment poses serious health risks, especially for children, including hearing loss, headache, and mental fatigue. To address this, we highly recommend installing acoustic shielding grids, and also vibration isolation pads.
To wrap up, we successfully built a Python-based noise and analyzer to monitor 5 different locations. From our findings, we discovered that noise level varied across all locations. The arcade recorded the highest noise level, making it the loudest environment, while the classroom recorded the lowest noise level and was the quietest environment. This data highlight the importance of noise monitoring in protecting public health, ensuring comfort, and creating a better environment for everyone. Based on our observation, we recommend several improvements. These include installing acoustic treatment materials, planting vegetation buffer to reduce noise, improving room layout, and carrying out regular noise monitoring to maintain a safe sound environment. In conclusion, all of the project objectives were successfully achieved. This project demonstrates that Python is an effective and reliable tool for environment noise monitoring and management. Thank you.
I just had to let you know you're